everyone. I'm studying in 8th class IIT, and I'm going to teach physics subject in from physics subject chapter 1 units and dimensions. In that, a topic called vernier calipers. Vernier calipers were invented by Paul Vernier in 1630, and it was named after him. It is an instrument which can accurately measure 0.01 meters, I mean not meters, mm, or say 0.1 mm and 0.01 centimeters. But the meter scale can only measure up to 1 mm, but it can go beyond the meter scale. So we'll use vernier calipers to measure more accurately than the meter scale. So it was invented by Paul Vernier. We have discussed it right now in 1630. And this device is made up of two scales. They are main scale, which is called as meter scale or a pitch, and a vernier scale. And this device looks like this. I'm drawing just rough and not detailed. Already I uploaded a video how it looks, and I'm going to label the parts of this. Okay, I should mark the regions. No problem. Okay, now this one is also known as pitch, main scale, and meter scale. And this is locking screw. I will explain what is the uses of these afterwards. This is vernier scale. This is blade. This is external jaws, and these are internal jaws. Okay, now here the purpose of locking screw is when we place an object, the vernier scale, I forgot to say one point, the vernier scale is movable and the main scale or pitch is fixed. So, if when we place an object here in the external or internal jaws, the vernier scale may move and give us wrong measurement. So, directly if we keep an object here, the length is up to here, so the vernier scale stops here, and if we if we screw it, the vernier scale won't move, it won't slide on the meter scale or pitch. So this is the purpose of locking screw. Hence coming to blade, it is used for measuring the depth of bottles and whatever. And here external jars are used to to measure outer dimensions, and here internal jars are used to measure internal dimensions like volume of a bottle or volume of something, a hollow cylinder or whatever. So I think you have understood these, the parts of the vernier scale and how it looks. I have already made a video how it looks, please watch that too. And then it can measure up to 0.01 centimeters. I have already said that it can measure up to 0.01 centimeters. See here, suppose assume that this is a meter scale. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here 1. Like this, some divisions will be on meter scale. See here, the distance between one line to another line is 1 mm. We can't measure beyond it, so we use vernier calipers to measure the measurements like beyond the meter scale, which is nothing but, it can measure more than accurately than the meter scale. So we use vernier calipers for accurate values or to measure accurate measurements. Here the internal jars are also used to measure the internal volume of a hollow cylinder or circle, and we can get diameter, radius and length by using external jars. I'll teach you how it will be. For radius, we can't get the radius directly. We know in mathematics we have already learned that radius equals to, 2 radii equals to 1 diameter. Same here, we will use this. If we want to find the radius here, radius equals to diameter by 2. This is the formula to measure radius. If we got radius of 4, to find, if we get the diameter 4, we can measure radius by using this formula. Diameter is 4, so I wrote 4, and here according to formula it's 2. So here we will get 2. Let's assume that is centimeters. So 2 centimeters. The diameter is, the radius is 2 centimeters. If in the question, if you have confusion how 2 centimeters was, I wrote 2 centimeters just to cancel 2 ones and 2 twos. And then if in question they give radius to find diameter, let's assume that the radius is 5. Here we wrote that 2 radii equals to 1 diameter. To find the diameter value, we should multiply 2 into the given value of radius. So the given value is 5. I am multiplying 2 to it, and it's centimeters. So here 10 centimeters. So the diameter would be would be 10 centimeters. This is how we calculate radius and diameter by using vernier calipers. And now I am going to teach you how we can get diameter from external jars and length from external jars. See, if a pencil is kept like this, it is called measuring the length. If the pencil is kept horizontally like this and fixed firmly, then it is called we are measuring the diameter of the pencil. So, in two ways, according to the way we keep, it depends on the way of we keeping the object in the instrument. So, it also depends whether the diameter or radius will come. I think the screen is somewhat blur. I think you can see now. So let's go back to the topic. And we already discussed that it has main scale and vernier scale. And it was invented by Paul Vernier in 1630. And we have already discussed how to get radius, how to measure radius and diameter using vernier scale. And what is the use of vernier scale and why can't we use meter scale instead of vernier scale? We discussed all these points. Now I'll teach you some formulas. I think you understood the parts. Here, see. Now the pitch is nothing but the main scale. So to calculate the pitch, one unit length by number of divisions in the unit. So, for example, how many one unit length? So, assume that we are taking centimeters. So, 1 unit. Let's take 1 centimeter by number of divisions in the unit. 1 centimeter equals to 10 millimeters. We all know that. So, let's write here 10. It becomes, if we remove centimeters for easier calculation, it will be easier. So, I am writing 1 by 10. In decimal form, it's 0.1 centimeters. So this is what is the pitch. This is the formula to calculate the pitch, and this formula is very important. So this formula should be verified and to solve the problems. LC is nothing but least count. And LC least count also have some formulas. First, it has two formulas. Let us see all those two. So here LC equals to, this is the first formula, 1 MSD minus 1 VCD. So you may have doubt that what is MSD and VCD. Here MSD is nothing but meter scale division, or main scale division, and here vernier, here should come vernier scale division. And the other formula is that 1 MSD by number of divisions, vernier scale divisions, which is we already discussed main scale. Main scale is also nothing but pitch. So we can write instead of MSD, pitch. Pitch by number of VSDs. I think you can't see here. I think you have understood. This is the formulas for the least count. And then to find the length, we have another formula. I mean not another, this is the only one formula to measure the length. This is nothing but MSR plus least count LC into VCD. Here you may get a doubt that here we wrote MSD and VCD. What is the difference between these two? VCD is nothing but we have discussed that vernier scale division, and coming to VCD, it is vernier coincidence division. I will explain what is VCD now. Listen carefully. Let us assume that it is a main scale. Sorry. And this is the vernier scale. Here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here it's, let us assume it pitch, I mean main scale, main scale, meter scale or whatever, and it is vernier scale. So here it is 0, 1, 2, 3, 4, 5. So here the 4 is slightly before the 4 of the meter scale. So here which division is coinciding with the division of the main scale? You may observe that this third division of the vernier scale coincides with the third division of the main scale. So this coincidence is nothing but vernier coincidence division. So to find length, we use this formula MSR plus least count into VCD. And then now is it visible? Okay. Now we have errors. So in errors we have 3 errors. Can you see? First error is zero error. Zero error is nothing but zero error is the same as there is nothing, no error in the instrument. The newly bought vernier scale has zero error, means it has no error. So what is zero error? So let us assume again this as the main scale and drawing graph. So here 0, 1, 2, 3 and so on. Here also 1, 0, 1, 2, 3 and so on. I mean it's here limited and here to limited, not more than infinity. So whatever, come back to the lesson. Here the vernier scale, I mean the 0, the vernier scale coincides with the 0, the main scale. I'll write here its main scale. I won't use main scale commonly, I will use pitch for everything. So remember that pitch is nothing but main scale or meter scale, and this is vernier scale. So when a 0 of vernier scale coincides with the 0 of the meter scale, it is called zero error, means there is no error in the instrument. And now coming to the positive error. This is somewhat, we have corrections for positive error and the negative error. Don't confuse for corrections in the positive and negative. I'll teach you it when the time comes. So let's concentrate on the positive error. So let's assume it again as main scale, I mean pitch. And this as vernier. Okay, no. Let's assume it here like this. This is 0, 1, 2, 3, 4 and so on. Here is 0, 1 and so on. So I'm not drawing all the divisions here. So let's assume it has the pitch or main scale for your understanding, and this has vernier scale. Now the positive error is nothing but when the 0 the vernier scale moves towards the right side of the meter scale, I mean pitch, then it is called positive error. Since these two won't coincide each other, I mean the 0 of the main scale won't coincide with the 0 of the vernier scale, and when the vernier scale is right side of the pitch, then it is called positive error. It's simple to understand positive and negative errors. See, in positive error, the 0 of the vernier scale should be at the right side of the pitch. In negative error, the 0 of the vernier scale should not coincide. Here in positive error too, it should not coincide and the vernier scale should be right side. And in negative error, same, it should not coincide with the 0 like here, and it should be left of the pitch. I'll write later when I teach you. So I think that you understood the definition of positive error, and for this correction is negative. This is very important. So we will confuse for positive error the correction would be positive but it is negative. So let's go. I think you have understood. For this we have the same thing, the same thing for the length. What we have, right? MSR plus least count into what? Least count into what? VCD, vernier coincident division, plus mean the correction is negative, so minus correction. This is the formula for the correction when we do. If the instrument is in a positive error before measuring, this is all before measuring. So we after measuring will get MSR, meter scale reading, that and least count we already know that 0.01 centimeters or 0.1 mm. We should take always 0.1 mm for this, and VCD, vernier coincident division. The vernier coincident division and the MSR, I mean main scale readings, will be dependent on the object you take. So the correction would be negative, I said. So here I took the minus symbol, I mean I subtracted the correction from the length formula. So this is nothing but we have already know that this is the length formula, MSR plus LC into VCD, and correction would be negative, so subtract the correction. So I think you have understood. Now let's go to negative error. In negative error, let us assume again this as the main scale. This is 0, 1, 2 and etc. This is nothing but pitch. And in formula, we won't write it as a pitch scale reading. We'll write main scale reading only. Remember it. The main scale have, I always say that the main scale have pitch, meter scale, main scale. So we should not write the pitch scale reading or meter scale reading. We should read it as main scale readings. So here vernier scale readings. Is 0 and 2. So here same like this, these two won't coincide. Here too these two are not coinciding, and you should observe small difference between the positive error and the negative error. So here the the vernier scale is on the right side of the pitch, but here the vernier scale, where I was reading, sorry, it's a mistake. The vernier scale is left to the pitch, main scale. So this is called negative error. When the 0 does not coincide with the 0 of the pitch or main scale, and the vernier scale is in the left side of the pitch, then it is known as negative error. Otherwise, for easier definition, you can say it as when the vernier scale is on the left side of the pitch, it is also known as negative error. For positive error, you can say that when the vernier scale, 0, the vernier scale does not coincide with 0 and it is on the right side of the pitch or main scale, whatever. But you should read main scale in formulas. Okay, let's go. For this correction would be, for positive we wrote negative, for negative we will write positive. So the same formula but a small change here, the plus will come here, MSR plus least count into VCD plus correction. Generally, if we don't know whether the correction is positive or negative, we generally write it as MSR plus LC into VCD plus or minus correction. This we will use if we don't know the correction is positive, the error is negative or the positive error, then we will use the formula MSR plus least count into vernier coincidence division plus or minus correction. Okay. I explain one example and I will close this, and again I'll close this after this example. Okay. Here they gave a 10 meter of main scale is divided into 10 equal parts on vernier calipers. If 10 divisions of vernier scale coincide with 9 divisions of main scale, calculate pitch, least count of instrument. So here we should calculate the pitch and the least count of the instrument. So first we'll calculate the pitch according to the question. As to calculate the least count, we should need the pitch, the value of the pitch. We don't know the value of pitch, so first we'll count the value of the pitch. So pitch, what is the pitch formula? 1 unit length, non-unit of length by number of divisions in a unit. So here 1 centimeter, I am not writing 1 centimeter, by 10, we all know 1 centimeter equals to 10 mm. So in 1 centimeter we have 10 mm. So number of divisions in a unit. So 10 mm are present inside the 1 centimeter. So I am writing 10 here. And then in decimal form, 1 by 10 is nothing but 0.1 centimeters. We got the pitch value as 0.1 centimeters, and now we should calculate the least count. Now we got the pitch, and the formula for this is pitch by number of VSDs. In question they gave that 10 divisions of vernier scale. We need VSD, vernier scale divisions. How many number of vernier scale divisions? They gave in the question that 10 divisions of vernier scale questions. So here in the question we got the information that the 10 vernier scale divisions. So we'll write it here like this. And the pitch, the value we got 0.1. So this is nothing but in decimal form 0.01 centimeters. So now I am closing the class. Thank you and support me by subscribing the channel IIT Ingibug.